Greetings to Dr. Nurul and fellow viewers. My name is Taufik Hakimi. Together with Asad, Warren, Ding, and Yangbo, we would like to present the continuation part of our project. Just to recap, next. Just to recap, our project is about predicting the top three profitable counters in KLSE Bursa. We want to gain insights into the highly dynamic market. For example, predicting when is the best time to buy and sell the stocks so that we can maximize our profits. Next. Therefore, we would like to exploit the potential of data science in the stock market by developing a predictive model and achieve at least 15% of MAPE. We want to be able to analyze the short-term price movement and also create a user-friendly dashboard, which includes the real-time data to enhance the investor strategies. So next is about our data modeling.
So thank you, Taufik. So I will present about the data modeling part. So after we completed the cleaning and virtualization in our assignment one, so we decided to we do the data modeling part in assignment two. And in the data modeling, we choose the LSTM and by LSTM as our project model. Is because it's extra from the literature review. The more impression literature review is from the Yang and Wang from 2022 and Sun and Sulfate from 2020, and they use their best model, which are the LSTM by LSTM. So LSTM is a type of algorithm used to analyze the sequences of the data, like the stock price over the time. So the next one is the by LSTM. It's similar to a LSTM, but we have trees is like upgrading the algorithm to have the eyes in the back of its hair instead of just looking forward in the sequences. It also can look backward. So, before we do the data modeling, we'll create the we created the feature engineering. So the first feature engineering we created is the lagging feature. Uh, we use the 4 hourly data to predict the cross price in the next time period. So we use the price 1 and until 4 to predict the price 5. This is the lacking feature. And then the second one is the RSI and MACD creation. RSI and MACD is like the most frequent technique that used by the investor. So we also like consider in our project. So we'll create this RSI and MACD by using the algorithm and put into our data set. And then before we put input into the model, we also will do the min-max scaling to our data set to make the scaling feature between 0 and 1 to make the model to easier to read the model the input data. So in our model, we use the LSTM and by LSTM. Also, we use the another feature is we use the LSTM with feature engineering, which are the RSI and MACD, and another model is without feature engineering, which don't have the RSI and MACD. So we totally have the 4 model for each constituent. So in the model evaluation, the best model for the 5148 constituent is the by LSTM with the feature engineering, which included the RSI and MACD. And then the second constituent is the 5168. Also, the best model for this constituent is the by LSTM with feature engineering. And then the last one constituent is the 7133. And then the best model for this constituent is the by LSTM without the feature engineering. After we get the data modeling, data evaluation, we done it. So we use the model prediction to serve as the strategy tools to trade for the trader by providing the clear indication of potential price movement within the trading day. By comparing the current of the or opening price with the predicted closing price, trader can make the informed decision about whether to buy or sell the stock. So the first scenario and second scenario is decision to sell or buy. So for example, if the price, for the price A, stock A in the price is 5 ringgit, and the model predict the closing price is 4.5 ringgit. So he will suggest the investor to consider to sell it. or maybe the price in the next time is the 3.5. So he will suggest the investor to buy it. Yeah. Next slide, I will pass to Asa.
Thank you, Warren. So the main data product that we have as a result of this project is actually our model. And how this model can be used in a dashboard is basically up to the developer of the dashboard to create a very nicely polished and shippable product that will delight the users. So that part of the engineering and development part is actually not the scope of our assignment. We would like to basically maybe expand on it in another project next time. So if you would like to access the dashboard, you can look at this QR code. We managed to deploy something with our Shiny. It's not basically our best work. The most of our effort is in the model and the data preparation that we did as data scientists. So let me just share the same dashboard that you can get from this QR code. So this is the dashboard that we have as a minimal, as a proof of concept. So this basically is an example of a candlestick chart, right? That you can see the historical price movements of the stock 5148, 5168, and 7113. And then basically what is the value that we bring is that you can actually look at the latest price movements, and you will notice that the last one here is a slightly faded candlestick. And this is basically because it's a predicted candlestick. So today is 5th June on the time of recording, and it's predicting for 6th June that the closing price will be 1.176. So 1.176 is higher than the opening price that it predicts. So it's maybe right now the closing price is 1.12. So it's showing that there will be a closing price difference that is profitable. So this would mean that the buyer is a green, meaning that they can buy. So they will probably want to buy in this case. Then you can also see for another stock. So this will be for 5148, right? But if you want to maybe look at 5168, it's also showing you an increase from 3.18 to 3.339, as a hike is possibly going to happen based on the past price movements, RSI and MACD of this stock. And similarly for 7113, it shows that there is a hike from 1.04 to 1.092. So this is the first tab. It's basically about predicted price. And there also has basically the reporting of the MAPE. So this is basically how risky it is to trust this model. There might be a margin of error about 5%. So this model is the most reliable. So it probably means that it's the best to consider investing here because it's a 4.8 MAPE. So all of this is basically sample of how the model can be integrated into a dashboard. Another part that we want to do in the dashboard is a model performance tab, which can help you to monitor where is the performance deteriorating or excelling. And this can help us to see if there is a data drift in the model and when retraining might be required for the model. So all of this is hosted on a public URL, and this is what we envision for our dashboard, to have a publicly accessible URL that anyone can use once we deploy the model for consumption by anyone. So I think that's all for our data product. I will pass it over to Ding to share about the reproducible uh, plan for research.
Oh, okay. So thank you, Asa. So I am going to introduce how our project can achieve the reproducible result giving 6.0. First, we ensure detailed documentation of our data science project describing how data was collected, cleaned, analyzed, and the final result. This meticulous documentation extends to script or code, providing clarity and facilitating replication. Next, release all the software and libraries used will delay Python notebook well Google Colab. And these are the library that we use in our project as well. So next, we cooperate with a systematic approach like the OSE NN framework. It allows us to demonstrate its step clearly enabling others to follow the same workflow and obtain the same result. To further ensure consistency, we test our script in various network environment among team members. Automation can also be considered by using script or pipeline, which help minimize human error and ensure consistent result with every run. Additionally, our data is collected from public sources well Yahoo Finance, and the software used is free and accessible through Coca-Cola. This approval requires no spatial access or permission, and it encompasses license and ethical considerations. By implementing these 6 points, our result can achieve reproducible. That's all from me. I will pass it to Liang. Thank you. Thank you.
Okay, thank you, Ding. I will introduce the summary of key findings. The first is develop and deploy a predictive model using 4-hourly financial data from Yahoo Finance. The second is analyze short-term price movements and provide intraday market insights. The last is develop a user-friendly dashboard that integrates the predictive model and real-time data analysis. So in conclusion, the integration of data science with financial market analysis has proven to be highly effective. Our predictive models achieve 1.53% MAP, and detailed intraday analysis uncovers fine trends. The user-friendly dashboard makes the advanced analytics accessible to investors without intensive technical knowledge, improving the overall user experience and investment decision making. So that's all. Thank you very much. Do you have any questions?